Something just arrived from outside our solar system, and right now, as it tears through our cosmic neighborhood at over 220,000 kilometers per hour, it is doing things that no comet has ever done before. And I need you to hear this, because this is not some tabloid headline. This is not speculation from anonymous internet posts. This is data from the Hubble Space Telescope, from the James Webb Space Telescope, from NASA's own fleet of spacecraft. And what they are seeing has divided the scientific community in a way we haven't witnessed in decades. The object is called 3IATLAS. It is the third confirmed interstellar visitor to ever pass through our solar system. The first was Oumuamua back in 2017. The second was Borisov in 2019. But this one is different. And what it is doing right now in February of 2026 has astronomers around the world watching it with every instrument they have. Let me walk you through why. If you care about what's happening above your head right now, if you care about science, about discovery, about the kinds of questions that keep physicists awake at night, then I need you to subscribe to this channel and become a member. We are building a community that goes deep on these stories, and your support is what keeps this kind of content coming. Hit that subscribe button, turn on notifications, and if you want to go further, join us as a member. It matters more than you know. Now let me take you back to where this started. July 1st, 2025. A telescope in Chile, part of NASA's ATLAS survey system, picks up a faint dot of light moving across the sky. At first, no one thinks much of it. There are thousands of these detections every year. Asteroids, comets, space debris. But within hours, something strange becomes apparent. The trajectory of this object doesn't match anything in our solar system. It's not following a closed orbit around the sun. It's on what astronomers call a hyperbolic path, meaning it came from somewhere else entirely. It's just passing through. Now here's what you need to understand. When scientists traced this object's path backward through space, it pointed toward the constellation Sagittarius, near the center of our own Milky Way galaxy. It had been drifting through interstellar space for billions of years, billions, and then, for the first time in all of those eons, it got close to a star, our star. And that's when things started getting interesting. Within weeks of the discovery, telescopes around the world confirmed that 3IATLAS wasn't just a dead rock. It was active. It had a coma, a hazy cloud of gas and dust surrounding its nucleus. That made it a comet, but not like any comet we've cataloged among the thousands in our solar system. Its orbital eccentricity, which is a measure of how curved or straight an object's path is, came in at 614. For context, a perfect circle is 0. Anything above 1 means the object isn't bound to our sun. Oumuamua had an eccentricity of 1.2. Borisov was 3.4. This thing came in at 614, the highest ever recorded. Its trajectory is nearly a straight line through our solar system. It arrived fast, it passed close to Mars, Venus, and Jupiter, and it's leaving fast. But here's where the story takes a turn that has genuinely divided the scientific world. Stay with me here, because what I'm about to walk you through isn't one anomaly. It's not two. Researchers have documented over a dozen distinct behaviors exhibited by 3IATLAS that have no precedent among any known comet in our solar system. Let's start with what the Hubble Space Telescope saw. On January 22nd of this year, 2026, something extraordinary happened. The Sun, the Earth, and 3IATLAS lined up almost perfectly within less than 1 degree of a straight line. This kind of alignment happens less than once per century for any given comet. Hubble was watching, and what it captured was remarkable. 4 distinct jets radiating outward from the nucleus. 2 pointed toward the Sun, 2 pointed away. The sunward jets were likely driven by sublimating pockets of carbon dioxide, and the anti-sunward jets created a brief but spectacular anti-tail that appeared from Earth's perspective to point directly at the Sun. Now, comets can produce anti-tails. That in itself isn't unheard of, but the structure of what Hubble captured was unlike anything previously observed. Ground-based measurements from the Very Large Telescope confirmed unusually high linear polarization in the anti-tail at 38%, suggesting an abundance of submicron silicate grains with a composition that doesn't match any solar system comet ever studied. Think about what that means. The dust coming off this thing is fundamentally different from anything we've seen, and it gets more complicated. Earlier observations, stretching back to the summer of 2025, revealed that 3IATLAS had wobbling jets. Teams at the Teide Observatory in Tenerife tracked the comet over 37 nights and found that the jets shift position approximately every 7 hours and 45 minutes. This oscillation, the first ever detected in an interstellar comet, suggests the nucleus is spinning with a period of about 15.5 hours, and that active vents on the surface are releasing gas and dust in rotating directions as the body tumbles through space. Here's why that matters. Normal comets develop tails that follow predictable patterns based on solar radiation pressure, pushing small particles away from the sun. But 3IATLAS has been ejecting particles that are far too large to be pushed around by sunlight. We're talking centimeter-sized, possibly even decimeter-sized chunks. The result is a pear-shaped outgassing pattern with the stem pointing toward the sun, and no traditional anti-sunward tail at all. This comet isn't behaving by the rules. And then there's the chemistry. If you're finding this valuable, hit that like button right now, because this story is about to get significantly more complicated. When spectroscopic instruments analyzed the gases in the coma of 3IATLAS, they found something that made researchers do a double take. The ratio of carbon dioxide to water was approximately 8:1. That is one of the highest ever measured in any comet anywhere. Most solar system comets are dominated by water ice. This thing is dominated by CO2. That alone suggests it formed in an environment completely unlike anything in our solar system, perhaps near a carbon dioxide ice line in a distant alien star system with conditions we can only theorize about. But the chemical anomaly that has generated the most heated debate is the nickel. Spectroscopic observations detected nickel vapor in the coma, but very little corresponding iron. The nickel-to-iron ratio measured by the Keck Observatory came in at 3.2, dramatically higher than the solar system average of roughly 1.0. Harvard astrophysicist Avi Loeb pointed to this measurement and noted that this specific ratio is characteristic of industrially produced nickel alloys created through what chemists call the carbonyl pathway. He argued that this has never been observed in any natural comet and could represent what he called a technological signature. Now, I need to be fair here, because this is where the scientific community splits sharply. NASA's lead scientist for small bodies, Tom Statler, has stated unequivocally that there is overwhelming evidence this object is natural. He has said it looks like a comet, and it does comet things. And Penn State astrophysicist Jason Wright published a detailed rebuttal of Loeb's anomaly list, pointing out that there is no standard nickel-to-iron ratio in comets, that the values vary widely, and that the chemistry can be explained by the fact that we are observing 3IATLAS at a much greater distance from the sun than we normally study comets. As solar heating has processed the outer layers of the nucleus over the past few months, the nickel-to-iron ratio has actually been declining. By late January, it had dropped to 1.1, remarkably close to values measured in solar system comets after subsurface material was exposed. So is this thing natural? That's the question. Let me tell you what happened next, because it only gets stranger. In early February 2026, researchers at Auburn University published findings from NASA's Swift Observatory showing the first ever detection of hydroxyl gas from an interstellar comet. Hydroxyl is a chemical fingerprint of water, and 3IATLAS was blasting it out at a rate of approximately 40 kilograms per second, while still far from the sun, much farther than where most comets switch on their water production. Meanwhile, NASA's SPHEREx space telescope, which launched in early 2025, devoted several observation runs to 3IATLAS. During its initial August 2025 pass, it saw very little activity. The comet's surface had been bombarded by cosmic rays for billions of years, creating a hardened shell devoid of volatile ices. But by December 2025, after the comet's closest approach to the sun cracked that shell open, SPHEREx detected a dramatic transformation. Organics, water, carbon monoxide. The comet had woken up. The Johns Hopkins team led by Carrie List described what they were seeing as a multi-billion-year-old comet essentially dying before our eyes, its ancient surface being stripped away by solar heat for the first time in its existence. And we're not done, because on March 16th, less than 3 weeks from now, 3IATLAS is going to pass within 53.6 million kilometers of Jupiter. And here's the detail that has raised the most eyebrows in the astronomy community. That distance is virtually identical to Jupiter's Hill radius, the boundary at which the gas giant's gravity dominates. The match is so precise that Loeb has suggested it could indicate intentional targeting of the Lagrange points around Jupiter, positions in space where gravitational forces create natural parking orbits for objects. Scientists at the Minor Planet Center are refining trajectory calculations right now to determine whether NASA's Juno spacecraft, still orbiting Jupiter, can turn its cameras toward the approaching visitor. Even a low-resolution image from JunoCam would provide the first close-range look at an interstellar body in history. Drop a comment right now. Tell me where you're watching from. I want to know how far this is reaching because this story deserves to be seen. Now I need to connect some dots here. The Breakthrough Listen project, one of the most sophisticated alien hunting programs ever created, turned the 100-meter Green Bank telescope toward 3IATLAS on December 18, 2025, less than 24 hours before the object's closest approach to Earth. They were scanning for narrowband radio signals, the kind of transmissions that any technological civilization would use for efficient communication across interstellar distances. They found 9 events worth investigating. Every single one was traced back to terrestrial radio frequency interference. No credible detections of any technosignatures originating from 3IATLAS. So let me be clear about what we know. This is a comet. The scientific consensus is strong on that point. It has a coma, it has outgassing, it has water ice, carbon dioxide, carbon monoxide, cyanide gas, and nickel vapor. It is composed of materials consistent with an icy body that formed around another star billions of years ago and has been wandering through the galaxy ever since. But it is also a comet unlike anything we have ever encountered. Its mass is roughly 1,000,000 times greater than Oumuamua and 1,000 times greater than Borisov. Its nucleus has been measured by Hubble at approximately 2.6 kilometers in diameter. It is moving faster than both of its interstellar predecessors. It has wobbling jets, a sunward antitail that persisted through a 16-degree gravitational deflection at perihelion, an unprecedented CO2 to water ratio, anomalous nickel abundances that defied expectations before gradually converging with solar system values, and it arrived along a trajectory aligned to within 5 degrees of the plane in which all our planets orbit. And now it is headed for a rendezvous with the largest planet in our solar system at a distance that matches Jupiter's gravitational boundary with eerie precision. Researchers have already proposed a mission concept to chase 3IATLAS. Using a technique called the Oberth effect, a spacecraft could perform a daring close flyby of the Sun to gain enough speed to eventually catch the comet. The journey would take between 30 and 50 years, depending on how much velocity the spacecraft could accumulate. It would travel over 700 astronomical units from the Sun, and if it succeeded, it would give us the first direct sample of material from another star system. Let me leave you with 3 things. First, 3IATLAS is the most studied interstellar object in human history. More telescopes, more spacecraft, and more data have been aimed at this comet than at Oumuamua and Borisov combined, and we still don't have complete answers. Second, the debate between natural origin and something more exotic is not fringe science. It is happening at Harvard, at Johns Hopkins, at Penn State, at NASA's Jet Propulsion Laboratory. The data is genuinely unusual. Whether the explanation is alien chemistry from a foreign star system or something we haven't considered yet, the anomalies are real and they demand investigation. Third, March 16th is 20 days away. When 3IATLAS passes Jupiter at the edge of its gravitational sphere of influence, we may see something new. Jupiter's immense tidal forces could fracture the nucleus, triggering fresh outbursts that reveal what's inside. Or the comet could pass quietly, continuing its long journey back into the void between stars, carrying its secrets with it. Either way, this object has already changed what we know about the universe beyond our solar system. It has shown us that interstellar space is not empty, that visitors arrive carrying chemistry and behavior that challenge our assumptions, that we need better tools, faster spacecraft, and dedicated missions to study the next one before it disappears. Because 3IATLAS will not come back. It's leaving our solar system forever. And the data we collect in the next few weeks may be all we ever get. The universe just sent us a message. Whether it's from nature or from something else entirely, the only question that matters now is whether we're paying close enough attention to read it. Make sure you're subscribed with notifications turned on because this story is far from finished. I'll be watching, and so should you.